We have understood the external loads acting on a structure. Now let's look at the forces that develop because of those loads, the support reactions that keep the structure in equilibrium. Think about a door hinge, a hanging rope, and a building column. They all support loads, but each allow a different kind of movement. And that's exactly why their reactions are different. Engineers don't memorize support reactions. They ask just one question: what movement does this support stop? And whatever movement is stopped, a reaction develops in that direction. So, if this movement is prohibiting translational motion, then we'll get a force F in that particular direction, and if it is prohibiting a rotational motion, then we'll get a moment. Let's M. And these are different reactions. So to understand things better, we'll take examples of different type of connections. And with this, the first connection would be cable. Let's say this is a structure which is tied to a cable with an angle theta. So the cable is prohibiting a movement in the direction it is tied to. So we'll get a reaction force along the direction, which is also denoted as the tension that you have widely studied in 11-12. Another type of connection would be roller connection. So here the structure is supported on a wheel or a roller and is resting on a flat surface. Since this wheel is free to move in horizontal direction but not along a vertical direction, so a force is developed in this particular direction F, and this is the reaction force. And in the later section we'll learn how to calculate this reaction force, but for now we have to identify the different type of reaction force that every connection is facing. So the third type of connection would be an external pin. Now this external pin allows the structure to rotate in this direction. Okay, let's say you have a pin, then the structure is free to rotate, right, along this direction, but it prohibits both the horizontal and the vertical movement. That's the result of which a reaction force is developed along those directions. Okay, now the second type of connection would be an internal pin. And here in this connection, two beams are connected with a pin in between them, and just as I told you, this pin allows free rotational movement, right, but it prohibits or restricts movement along x and y direction. So this pin will create forces in those directions. Let's not worry about which direction the reaction force is developed on the structure. The mathematics will work out and we'll eventually know what the direction is. And one of the most famous type of connection that you'd be repeatedly studying is a fixed support. So here the beam is connected to a wall, let's say. Now this wall prohibits both a rotational movement Also it prohibits it from moving in x direction and y direction. So we are getting a force in y direction, in x direction, and also a reactional moment that I have told you this one. Okay, right?